When it comes to breaking walls, 3D scanners are where it's at. My name's Sebastian, welcome to another episode of the 3D Show. In this episode, we're talking about expanding manufacturing facilities. We got this big wall right here, right? Imagine when they're tearing this wall down, but they have no coordinates. Well, 3D laser scanners help with the coordinate system in that process. It helps create the coordinates from point A to point B, how dense, how deep, and how thick you get into it. So I want to talk about a 3D laser scanner and a case study where we're using terrestrial laser scanning data, and how do we bring that together, reality capture tech, before we break ground. My name is Sebastian. Welcome to another manufacturing plant. Welcome to another episode of the 3D Show. I'm going to see you super soon. Talk to you soon, everyone. Peace.
Well, that was a good teleportation. I was from an industrial plant back to the attic. Who knows? Hey guys, my name's Sebastian. Welcome to another episode of the 3D Show. Welcome back to the attic. And in this episode, as you know, we're talking about industrial facilities, about not only breaking ground, penetration, but also how do we leverage reality capture technology in your industrial facility when it comes to expansion. Let's start from the top, everyone. Industrial expansion. So let's just start with the definitions here. I want to first talk about retrofitting, revamping. Hopefully the images are good. But with retrofitting is not altering the processes of your industrial site, but adding new things, introducing new machinery, new lines, new robotics. While when it comes to revamping, it means altering the entire process of that site. So revamping, new processes, retrofitting, maintaining the old processes. Now we're seeing a trend more and more in Canada and the United States. In Canada, we're doing a lot of retrofitting scanning, and in the United States, we're doing a lot of revamp scanning. When it comes to actually the regulations in Canada, because we have an issue of supply and demand, which really sucks, that's why I live in an attic and everything's super expensive here. When it comes to the whole regulation aspect, Canada, we have a supply and demand issue. It's so much regulation just to build a house, so much regulation just to do an expansion. When they're doing these operations, they need to maximize their space. While in the United States, when they want to break a wall, they break the wall. Of course, depends on the state, depends on the laws and regulations, but we're seeing a lot more of, hey, I have this site, I want you to scan this site so I understand the as-built conditions, but I also want to break this wall down and expand it, and then make a new process completely. So they're doing a lot more revamping where they can add an additional line and add an additional process and add an additional product output because of that regulation. So I'm starting to see that that's happening more and more. Now let's talk about the whole aspect of expanding an industrial site. I'll bring you a real example. With that site that we're talking about, can't bring up where exactly it is, but I can say that we were actually scanning the inside of the site and the outside of the site to understand what the wall's thickness, not only the wall's thickness, but also the processes inside that wall, behind that wall. So then I understand what are the pipes going through, what are the pipes going out. That way the engineers can then make their design and their process suggestions to the owner. So there was an engineering integration company and the owner, and what we were able to do is we were able to scan the owner's facility, and then we gave the data to the engineering company, and then they could do engineering verification checks to see what do they need to do in order for them to achieve the objective that they promised the end client. They use the data once again as a connective tissue. But there's the other part that I like about it. I'm able to do clash detection. Why does that matter? Because I brought up coordinate systems. So if I'm able to understand the as-built dimensions and the as-built information of coordinate systems in the facility, I'm able to then bring new elements in IFC file. Boom, you do a clash detection, and then you're able to do and see, hey, this foreign element that hasn't been even introduced to the site, I can check if it fits or not. Once we have the data-driven decisions, the data-driven information, the engineering team feels comfortable with their design plans. You got to go from engineering to construction. From a construction standpoint, we need precision in execution. Because the engineer and the construction team is talking amongst each other, they have the point cloud technology, they have the point cloud data, they probably have an as-built CAD, and this will help the construction crew for construction validation. So with the construction validation, it's going to be periodically verified that if the as-built conditions of that BIM that was created by the 3D scanning company, their construction team is going to validate everything that's happening there on the site, but that's going to help them in the execution process. This is when they're able to actually execute things properly with some degree of guarantee and reducing the downtime and the mistakes. Now, I have an amazing story. We had the opportunity of working in an alcohol facility, and in this alcohol facility, we talked to the very high-end construction crew, and one of the members of the team was able to tell us that if they don't actually have that construction done right, or there's actually more downtime because the construction crew was not efficient, they're charged a specific amount in the contract. So you need to minimize that by leveraging the reality capture technology, 3D laser scanning, and then of course dimensional control. So when it comes to dimensional control, technology aids in achieving precise dimensional control critical when installing new machinery or fabrication within the tight tolerances, which is common for the industrial settings. We have to understand that industrial sites have very tight tolerances. And the third part is operational transition and asset management. So why do I mean about operational transition? Well, number one, lifecycle management, meaning the enriched BIM model with reality capture data informs lifecycle management, allowing engineers to predict maintenance schedule and optimize the plant's operations. So when you scan and when you're doing these expansion projects, this allows you to keep tabs of what your current site conditions are, but not only that, being able to see what your assets are in that site. Then that goes into the asset management side. Is an expansion, when expansions are complete, engineers catalog new assets into the BIM model, new assets into their CADs, and more importantly, catalog everything that they did, because they need to tell the client, here's the bill of goods, here's the building material we use, and here's everything. So that allows their finance team to be able to categorize this. And this allows you to actually introduce this BIM model, the actual real concept of building information management, which is this everlasting organic document. Hopefully that was very comprehensive. Hopefully that was helpful. Hopefully that explained to you how does reality capture technology really help in expanding and how do you use it before you break the ground. Remember, data is coordinates at the end of the day, and people work with coordinates. They understand that point A goes to point B, and if you have a 3D, an X, Y, and Z formula, it's so much easier. You're able to understand so much more, but you need to understand how do you leverage that information. My name is Sebastian. Thank you very much for listening to this episode of the 3D Show. We're going to have a lot more episodes coming out. I'm going to see you super soon. Ciao, everyone. Peace.